incorrect to not add them, okay? I know we've said that in our notes, we said it multiple times, SO4, okay, no parentheses. Potassium, potassium is a -1 because it's a metal in group 1. Chlorine is a non-metal in group 17, that's a +1. Crisscross those. We don't ever put anything for the number 1, so KCl is how that's gonna look. Turn the page. And I'm gonna leave it here just for a second, just to make sure everybody gets all the answers.
Yeah, I was gonna say, aren't they flip-flop?
Oh, yeah. A metal and a non-metal, positive and negative, good call. There you go. Next one, write the appropriate bond angle for the molecule geometry. It says here, just type in the number. So I was hoping in parentheses when I wrote that in there, just type the number. I was hoping that made it a little bit more simple for you. We have it in our notes. We also have it as well in the little chart that we have. So I'm gonna come over here to the notes over here. And again, we're talking about molecular geometry, okay? And I'm gonna go ahead and pull this out. We're looking at the molecular geometry name, and we're correlating with the bond over here, okay? So I'm gonna have both of those right here as I look at this one, the first one, triangular pyramid, should have been pyramidal. It's gonna be 109.5. Here it is, 109.5 in our notes. The next one is linear. Linear is 180. And you know it's degrees, but I didn't want anybody to stress on having to do the little degree sign. That's the reason why I said just write the number down. The next one says bent, and we know that H2O is a great example of a bent, 120 degrees. Tetrahedral, on tetrahedral, it's 109.5 degrees tetrahedral. And I was hoping those were, you had them in your notes, hopefully then that would have been fairly easy for you, hopefully. The next one says here, pick the correct Lewis dot structure for the following molecule that contains oxygen, nitrogen, and fluorine, okay? Oxygen, nitrogen, and fluorine, and this was a tricky one. And I said, you know what, I thought about it and I was like, ooh, I like it because this one is gonna challenge you. You really had to use our notes if you were doing the Lewis dot structure. And I believe that not only page 1 would have helped you in your notes, but also this page over here when we did those single, double, and triple bonds, okay? So let me draw this out if I was doing the Lewis dot structure. Well, first thing is I've got to decide, well, heck, who is gonna be my CA? Remember, we have a few rules. Hydrogen will never be a CA. If there's carbon, that's a guaranteed CA. Other than that, our rules are over here, and I can pull them up for us. All right? Hydrogen will never be a CA. Carbon will always be the CA. If not, and you're still looking, trying to figure that out, well, then you're going to have to go to the one who's usually the most left on the periodic table, if that makes sense. The one that is the most left on the periodic table. And that's where I got this from the notes, straight right here onto the notes. So now in that case, Ken, I've got nitrogen, fluorine, and I've got oxygen. Well, fluorine, if I'm looking at the periodic table, because I'm looking back there behind y'all, fluorine is all the way to the right. And then and they're all like in the top row together on period 2. After fluorine is oxygen, and then after oxygen, it's nitrogen. So nitrogen is the most left. So nitrogen has to be the CA. In that case, then, we can knock out that one, that one, that one, and that one. Look at that. Do you see how quickly, knowing that those rules, I was able to knock all of the others already out of the way? It has to be carbon, never hydrogen, or the one that is the most left. And nitrogen is the most left on the periodic table. Now let's keep going now. I've got to decide, well, what's going to happen? Who's a single bond and who's a double bond, okay? So in this case, I'm going to come over here, I'm going to do nitrogen. Nitrogen is group 5. And so in that case, they're going to gain 3 extra negative electrons. But group 5 means that they have 5 valence electrons. 1, 2, 3, 4, 5. And this is how I did this answer. Oxygen, okay? Well, oxygen is in group 16, means that they have 6 valence electrons. 1, 2, 3, 4, 5, 6. And then again, we've got fluorine, and it didn't matter whether you put the oxygen that side or that side, it doesn't matter. Fluorine's in group 17, so fluorine, 1, 2, 3, 4, 5, 6, 7. Now, in this case, who is gonna bond with who, or what electrons are gonna bond together? Well, if nitrogen has to be in the middle, okay, whether I flip them this way or that way, I can see that this oxygen is gonna bond here. This valence electron of the oxygen is gonna bond with here. And this fluorine is gonna bond over here. So now the nitrogen-oxygen has a double bond, and the fluorine-nitrogen has a single bond. Now you can match to see which one is correct with it, and it's gonna be this one, okay, is the correct answer. But this is how I did it, okay? I literally went back to the Lewis dot structure so I can decide who's gonna have the double bond and who's gonna have the single bond. And knowing the rules, nitrogen has to be the Ca. That's my correct answer, okay? Hopefully y'all are able to do that one. It was, I thought, a little tricky. I'm telling you, I promise you it's gonna be similar to that on the test day. Let's turn the page. One question, I apologize, it's on the page and it just takes up all the space. Pick the correct Lewis dot structure for the following molecule CH4. Okay, well in that case, I know the C is definitely gonna be the Ca, and the H is gonna be what we call terminal atoms, right? And so let's look. Then it tells me that there's 4 H's. So in that case, it definitely can't be U. Now I'm down to 1, 2, 3, 4. What was the other rule in our notes? We said that hydrogen can only have 2 electrons and boron is 6. So this hydrogen has too many electrons on hydrogen. Not, I can't even spell today. I'm horrible today. Missing 3 times hydrogen, because that's how many we're missing. So now we're down to here and here, okay? Carbon is gonna have to achieve that octet rule, which means that he has to have 8. And I don't know if I said this or not, and if I haven't, let's listen to it now, because you're gonna see some questions on the test that has the positive and the negatives. And the positive and negatives indicate that they are donated and accepted. Meaning that +1, right, means that they have an extra negative electron, and -4 means that they accepted an extra electron, they donated 4 electrons. Now, what does accepting and donating mean? What type of bond? Ionic, right? And we know that lines mean sharing, okay? So let's go ahead. Knowing that, now that you've heard me verbally say it, hopefully you're thinking it can't be that one. But let's double check real quick. 2, check, 2, check, 2, check, 2, check. So the hydrogen are good. Carbon, 2, 4, 6, 8. Has to be that one. And the reason why it's not this is because of the positive and negative. Means accept or donate it, right? Which, CH, which is ionic bonding. Okay? So I just want to just toss it out there just in case. I don't know if I said it or not, but I want to definitely make sure. The other thing that you may see or that you're going to see on the test day is you're going to see brackets. And brackets indicates accepting and donating. Okay? Brackets also indicates that. Also, another thing that indicates ionic bonding is arrows. So if they say that this one's gonna go over here and this one is gonna come over here, that's also an indication of an ionic bonding, okay? So brackets plus a negative and the arrows are all three indications. What is it when it comes to covalent? Lines, lines, okay? Let's keep going, and I might be wrong, but I think we're down over here to the last part. Okay, so polar and non-polar, they were in our notes, I know we talked about it. Let me just kind of go back as a quick little recap of it, because I know I'm taking up all of our time and we haven't even done our foldable yet, and that's okay, we can just do part of it if we need to today and finish it up later. It says here, polar and non-polar. Now, how do I know it is and isn't? If I have two atoms, just two, nope, 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 then I can go to my electronegativity chart, look at that number, and do the subtraction. Super easy. And then I can see, oh, okay, where does it fall in the range up? Is it covalent, ionic, ionic, covalent, ionic? Okay, but since I have more than two atoms bonding together, now in that case, you're gonna have to do the drawing. And the drawing will always override and supersede anything else, okay? So in this case, I have carbon, hydrogen, and we just saw that on the previous page. We can see that, what it looks like. And again, when it comes to polar bonding, I don't care if you cut it this way or if you cut it this way, it is going to be completely symmetrical, right? If I cut it this way, either way, out of those three ways, this is going to be symmetrical, this is going to be non-polar, okay? What's an indication that it's polar? Lone pair of electrons on the Ca. Now I'm just going to skip a little bit real quick, only because I know H2O. Here's my O and my H's, because I have two sets of lone pair of electrons. This is definitely going to be polar. And we said that water is the universal solvent. That is definitely going to be polar. The next one here is, let's see, I'm just trying to see if I can find something that's super easy. CO2. So on CO2, it looks like this. C, line, O, dot, 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 dot. And if I cut this smack dab in half, this is definitely going to be non-polar. Okay. The next one here, let's see, I'm trying to see who I have that's similar to it. SO2, and I'm looking out of our notes, that's where I'm getting my answers really quick. It looks like this, O, dot, dot, lone pair, lone pair, lone pair. But Ms. Munson, I thought you said that if there's those lone pairs over there, then that's probably a good indication that it's gonna be polar. If there's lone pairs on the Ca, not on the terminal atom, okay? And not only that, but there's equal amounts. There's two lone pairs here and two lone pairs here. Again, this is gonna be non-polar, okay? And then the last one, N, is gonna be my Ca, and then I'm gonna have three Fs, F, F, F. I've got 2, 4, 6, nitrogen has to have 8, so look at that already. I've got lone pairs without even doing, right? Because nitrogen has 5 valence electrons, fluorine has 7, 7, 7, 5, 10, 15, 20, 2, 4, 6, 26. Right, doing all of that math and stuff, I don't have to go any further. I can see this, and so this is gonna be polar. Okay? So, I think we're finished, and I'm so sorry, I know it was a long quiz, but I thought it was really good to go over all of it, okay, before we go any further. So I'm gonna move this out of the way. If anybody, after class would like to come and take a picture of it, you're more than welcome to. I'm suggesting go back, because now it's open on Blackboard. Please go and double check it. I could have screwed something up, but give me like a day so that way I can go and fix any mistakes, because you probably got it correct, okay, but it probably marked it wrong. So today we're also gonna look at homework number 4 and homework number 5. Homework 4 and homework number 5. It looks like that. And then it says we're gonna go through and work on that foldable as well. We kind of have a lot that we're shoving in, because we lost some days with all this madness. So homework. I would have to say if there's any questions, you definitely let me know. But can I give you the answers and y'all take a picture? Because I know I'm trying to take up y'all's time. Now I'm gonna leave it here. You can take a picture, but also, and I will video this, because I videoed homework 1, 2, and 3 already and posted the answer keys. I'm gonna video this at home and post the answer, a picture of the answers too. But at this moment, is there anything that looks really off, like I'm kinda unsure, I think you got that wrong, or did I get it wrong, Ms. Mason?
This is homework 6, not 4 or 5.
No, this is homework 4, this is last year's numbers,
Oh, okay.
because we combined, you know, the way we combined everything this year, our numbers are a little off from last year, okay? A biggest thing that students forget is, and I screw that up, right? Remember, if you have some of them, they may be hydroxide is a polyatomic. You saw me screw that up earlier. Acetate is a polyatomic, right? Phosphorus versus phosphate versus, you know, you've got to make sure, because I screwed that up too earlier today. Nitrate is a polyatomic though, okay? If the polyatomic is gonna bond with metal, then we need to reduce. What if a polyatomic is gonna bond with another polyatomic? Do we reduce? I guess you can stop for a moment and ask yourself, if a polyatomic and a polyatomic bonding together, in our notes, are they under the ionic or are they under covalent bonding? They're under ionic. And when it comes to ionic, we need to reduce, if it comes to that, by any chance, okay? But any kind of ionic bonding, let me toss it up there as a reminder, metal and non-metal, metal and polyatomic, polyatomic and polyatomic, polyatomic and non-metal. Those are all considered to be ionic bonding, okay? And they must be reduced. I don't think we probably had any problems with this. Let's go to the next homework, which looks like this, homework number 5. Now we're getting to the naming, and there are some rules in the naming. I am going to take a picture, I'm gonna post it, I'm going to video it. I'm gonna do all of that, just in case if you wanna go back and watch me answer 1 or 2 questions particularly. The answer key is what I need to find. We can go through the whole thing, I just don't want to take up so much of your time. Maybe calcium, iodine. Maybe not bonding. Maybe not bonding. That's just the first part. Let me find my key that has all of it. That's obviously missing so much. Now, I videoed those notes and I'm afraid that some of us are still might be like a little confused, like, whoa, wait a minute, this is kind of weird because of all the rules. And so I want to make sure that we go over this together. And I'm gonna say one more time, I think the foldable is gonna be the best thing for us to help us understand it a little bit easier. I'm just trying to find my homework so that way it can be easier just to show you all the answers at once. Ah, here it is. Okay. So here are all the answers. It says write the formulas here. So calcium iodine, okay, we had again, calcium is a metal, that's a +2 charge, iodine, it is a non-metal, it's in group 17, so it's a -1 charge, crisscross them, that's how I got CaI2, okay? nitrogen tribromide, okay, it's how you pronounce this. Tri is the prefix, bromine is gonna be the base word, and then ide is the ending or suffix. It was videoed, hopefully we're gonna go over it in the whole thing, okay? So nitrogen, we write the nitrogen first. The tri indicates that there's 3 bromines, and that's how we write it. Hexacarbon, okay, so in this case, hexacarbon, hexaboron. Hexa means 6, boron or boron, sorry, is a B. So B6, mono, which means 1, silicide. Ide is the suffix, silicon is the base or root word for Si, and mono means that there's 1, so we don't put nothing behind it, and that's how I got that answer, okay? Sodium sulfide, okay? Sodium, which is a metal, all right? Sulfide, all right? Sulfur is the second name. There's a suffix at the end, IDE. I've got to crisscross them. Sodium is in group 1, so that's +1 charge. Sulfur is in group 16, so that's a -2 charge. When I crisscross them over, that's how I get Na2S, okay? Chlorine dioxide. If I see a prefix on the first or second word, or both the first and second, that's an indication that it's going to be a covalent bond. When it comes to prefix, you're just gonna write the name, the initials, so Cl for chlorine. There's no prefix, so that means that it's a mono, a 1, don't write a 1. Di means 2, oxygen, so oxygen with a little 2, okay? There was a few diatomics, chlorine gas and nitrogen gas, okay? They may just say chlorine and they just might say nitrogen, and they may not use the word gas. It's still a diatomic, and you just write Cl2 or N2. But you have to have the 2 because we know the 7-7 rule from the diatomics, okay? Now over here, they gave us the formula. They wanted you to write the names. Again, making sure that you know, and this would be me personally, if I'm gonna do this, I would probably go ahead and put, is an ionic bond or covalent bond. Ionic or covalent, because covalent bonds has prefixes, ionic bonds do not have prefixes. And that's how I have it separated and memorized in my head, okay? So there's the answers. I'm gonna personally go through and video me going through it, so hopefully that would help you out a little bit if you have questions. Now this is homework number 4 and 5. Homework 6, we were definitely gonna take a grade for it when we come back, but I just wanted us to kind of get back on track when it came to this, all right? So let's look at, and we have like pretty much no time left.